Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by Techstrong and Gremlin. My name is Cody J. Brown. I'm the host of Techstrong Learning. We have an exciting presentation ahead of us, but first, I have just a couple of housekeeping notes. First, today's session is being recorded, so if you miss any of our discussion, or you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live webinar today. If you have any questions for Julie, we want you to submit those using the Q&A tab on the right side of the screen. That's also where you'll find the chat tab, and you can use that to engage with the rest of your fellow audience members. Finally, at the conclusion of our webinar today, we will be giving away 4 $25 Amazon gift cards, so be sure to stick around. So today, to kick off our webinar, we will be driving down the road to reliability, and I'm joined today by Julie Gunderson, Senior Reliability Advocate at Gremlin. Julie, thank you so much for joining me today. I'm going to give you the floor.
Thanks, Cody. I'm really excited to be here to talk about why resilience is important, what reliability means. And when we look at reliability is really no accident. If we have learned anything over the years, it's that reliability takes work, a plan, strategy, and a lot of tactical action, which include teamwork and collaboration. So we're going to talk about how you can make your systems more reliable and how everybody can participate in that. And so I'm not sure if everybody remembers this major AWS outage that is currently loading on my screen right now and not playing from the last couple of months. But this was a major 5-hour outage that had all sorts of downstream effects. And that's because our systems are complex and failures are inherent to complex systems, and our systems depend on other systems. And if you think that, okay, well, then I'll just avoid that by not using AWS. This also happens with Google. This happens with Azure. Outages happen. And so it's important to understand how we can prepare for those. Really quick, just to let you know, I'm Julie Gunderson, as Cody mentioned, Senior Reliability Advocate here at Gremlin. You can find me on Twitter at Julie_Gund. You can also email me at julie@gremlin.com. You can find me on LinkedIn. There are multiple ways to reach out to me. Prior to joining Gremlin, I was a DevOps advocate over at PagerDuty, where we focused a lot on incident response. And a lot of these things tie in together when we talk about the reliability of our systems. So I want to kick it off with this amazing resource. This is a book called Accelerate, written by Dr. Nicole Forsgren, Gene Kim, and Jez Humble. And if you have read it, awesome. If you haven't, I would highly recommend grabbing this book. It's about building and scaling high-performing technology organizations. And I'm going to touch on a few of the topics that they discuss in Accelerate. So these folks have done an amazing job of collecting all the research they gathered from practicing DevOps over the years, and also creating the DevOps survey report that Puppet would send out. And what they did is they took 4 years of research, and they came together to analyze that data in a great way and to bubble it up and say, these are the most important things you need to think through when you're creating high-performing technology organizations and building and scaling those high-performing teams. And in Accelerate, they focus a lot on tempo and stability. And a lot of times, people ask, well, how do you measure chaos engineering? How do you make sure that the work you're doing is the right thing? And how do you prove that what you did actually makes a difference and is able to move the needle, especially if you have a lot of people working on different projects? And it's really important to measure back and say, well, this is what we did, and this is how we moved that needle, and this is the ROI that we got from doing this work. And over the years, a lot of research has been done and books have been written on how to improve the resilience of our software. So I want to deep dive into some of the key practices to improve the key measures of tempo and stability outlined in the book Accelerate. And when we look at these practices, I'm talking about chaos engineering and game days and disaster recovery. So I'm actually going to show you some practical tips you can put into action that are focused on, resource consumption or capacity planning, decoupling services. And so let's go ahead and kick off with a little bit about what is tempo and stability. So tempo is measured by deployment frequency and change lead time, where stability is measured by mean time to recover, or MTTR, and change failure rate. If we break that down even further, deployment frequency would be the rate that software is deployed to production of an app. So for example, within a range of multiple times a day to maybe a really long deployment frequency like once a year. Now, tempo is that change lead time. So that's the time it takes from a customer making a request. So, that customer wants a feature to that feature being built and rolled out to where the customer can use it. And so that's the time that it takes from that request to the request being satisfied. And then stability is that mean time to recover. It's that time it takes for a company to recover from downtime of their software. And then we look at stability change failure rate. So that's the likelihood of defect changes. So if you roll out 5 changes, how many of those changes will have a defect? How many of those changes might you need to roll back or might you need to apply a patch for? So is that 1 out of 5 or 2 out of 5? And these are the types of metrics that Accelerate recommends that you measure. So back to the key practices. As I mentioned, the key practices are chaos engineering, game days, and disaster recovery. And according to Accelerate, you should focus on improving reliability because it's the foundation that enables you to have that really great tempo. It enables you to improve developer velocity, which makes so much sense. But what's really nice is they're backing this data up with over 4 years of research, because we know that engineers feel more confident when software is reliable. They feel more confident to write new code. They feel more confident that their features that they're building are going to work well. They understand all the different failure modes because they've been focusing on reliability and they've been trying to improve that reliability. So that actually makes it so they're able to ship code faster and more reliably. And it's really exciting when you can ship new features that work and that you can trust that those new features will meet requirements. And so in Accelerate, they say that we should build systems that are designed to be deployed easily, can detect and tolerate failures, and can have various components of the system updated independently. And there's a lot of different things going on that are really great to work towards here, but I'm specifically going to focus on detecting and tolerating failures specifically. So what's the best way to know if your system can detect and tolerate failures? You can definitely type your guess in the chat. I'm just going to let you know, chaos engineering. It's the best way to know that your system can detect and tolerate those failures because you're purposefully injecting real failure to see how your systems can handle that. So I want to look at some of the basics of chaos engineering. Chaos is really a misnomer because what we're doing is we're really simulating the chaos of the real world in a controlled environment. And chaos engineering, we're starting with a methodical and scientific process. We're starting with a hypothesis. We're experimenting to validate that. We're starting small and moving into larger environments. We're communicating with everybody. We're making sure that we are sharing our plans. We want to think through things like, what if there's an incident? You don't want to negatively affect other teams. We're making sure we're sharing what we learn, because chaos engineering is all about learning, because we're making people better engineers and we're making our systems more reliable. And it's also about iteration. So again, we're creating a hypothesis, we're running experiments, and we're creating tasks to improve software and processes. We're updating these hypotheses and we're repeating. So to kind of sum it up, chaos engineering is thoughtful, planned experiments designed to reveal weaknesses in our system, both technical and human. So we want to think about, where is our technical systems? Where are they broken or insufficient? Where does the user experience break? Does our monitoring and alerting work? How about auto scaling? Can we scale up? Do we scale down? Or retries? And we want to think about our human systems as well to maybe understand where those processes are broken or ill-equipped. So, did the alert rotation work? Was there the right documentation and playbooks? Did the escalation processes work? And I do want to point out here that we are not trying to test our people or catch them off guard. Chaos engineering experiments should be planned and shared widely throughout the organization, but we want to make sure that our people are equipped to handle those incidents to reduce that mean time to recovery. And now is the best time because our systems become more complex over time. So we want to start when things are less complex. So I do want to talk a little bit about how you apply the scientific method to chaos engineering. So to measure how systems change during an experiment, it's important to understand how they behave now. And this involves collecting relevant metrics from target systems under normal load, which will provide a baseline for comparison. And using this data, you can measure exactly how much your systems change in response to an attack. And it's okay if you don't have baseline metrics, you can start collecting those now, and then you can use chaos engineering to validate those metrics. And then one of the most powerful questions in chaos engineering is, does this work the way we think it does? So once you've got an idea of how you think your system will work, think about how you're going to validate that. So what type of failure could you inject to help prove or disprove this hypothesis? What happens if your systems don't respond the way you expected? So you've chosen this scenario, this exact failure to simulate, to inject. What happens next? And this is actually a really excellent thought exercise to work through as a team. By discussing the scenario, you can hypothesize on the expected outcome when running in production. What will be the impact to customers, to our service, to our dependencies? Once you have that hypothesis, you'll want to determine then which metrics do you measure in order to verify or disprove that hypothesis. And here it's really good to have a key performance metric that correlates to customer success, such as orders per minute, or if we look at like Netflix, stream starts per second. Kind of as a rule of thumb here, if you ever see an impact to these metrics that are affecting customer success, you want to halt the experiment immediately. And after you've formed your hypothesis, you want to look at how you can minimize your blast radius prior to your experiment. So the blast radius is the subset of a system that can be impacted by an attack. The worst case impact of a failed experiment, and it's usually measured, as I mentioned, in customer impact, i.e. 10% of customers would be impacted, but it could be expressed in hosts or services or other discrete parts of a customer's infrastructure. When running chaos experiments, it's recommended to start running the smallest version possible because you want to limit that blast radius as you're starting out with verifying that hypothesis, and then you can scale that larger over time. So you want to start with the smallest possible experiment to test in your system, and from that, expand that blast radius out. You also want to always have a backup plan in case things go wrong, and accept that sometimes even the backup plan can fail. So you want to talk through how you're going to revert that impact. One of the core aspects of Gremlin is safety. So all of our attacks can be reverted immediately with a big red halt all button, allowing you to safely abort and return to a steady state if things go wrong. So our agents will also immediately halt any ongoing attacks if they lose connection with the Gremlin control plane. And after you've run your first experiment, hopefully there's likely going to be one of two outcomes. Either you've verified that your system is resilient to the failure you introduced, or you found a problem that needs to be fixed. And both of these are good outcomes. On one hand, you've increased your confidence in the system and its behavior. And on the other hand, you found a problem before it caused an outage, before it impacted your customers, and you've been able to fix that. And so you want to make sure that you've documented the experiments and the results, because as I mentioned before, a key outcome of chaos engineering is learning. And through these experiments, you're learning about your systems, you're validating your hypothesis, and you're teaching your teammates, you're building a culture around reliability here. So share the results of your chaos engineering experiments, because that's going to help other teams understand how to run their own experiments and where weaknesses in their systems are. Now, just a few, how do you get started? So as I mentioned, you want to start small and increase the blast radius. You want to be careful. Start on a single service or host, not the whole application or fleet. You want to start in a controlled environment. And I mentioned this before, we're not trying to catch our folks off guard. You want to start with a team that's ready, and then you want to expand that blast radius. And you can adopt the practice in development so that engineers are really architecting for failure. So get confident testing and development, and then move to staging. And then you start small in staging and expand that blast radius, and then finally move to production. And you're starting small and increasing. So this is really similar to how we do development, right? We don't need to overthink it. You want to work iteratively like you would with code. Move up the environments like you would with code. And a lot of folks know how to do this. So I want to show you a demo so that you can see what this actually looks like in real life. So this is a really cool open source project that you can find on the Google Cloud Platform GitHub webpage. It's a repo called the Bank of Anthos. So definitely check it out. This is the architecture diagram, and it's really great for learning how to practice chaos engineering because it's an internet banking application. It has multiple languages, so both Python and Java, which is really common these days when we're working on systems. There's often multiple languages. Then there's two databases, an accounts database and a ledger database, which are running on Postgres. And then we have our transaction history service, a balance reader service, the ledger writer, the context user service, our front end, and a load generator. So this is what it looks like. One of the questions we want to ask ourselves when we're starting to practice chaos engineering is, what is our hypothesis, right? We want to think through what's going to happen if we do something, say, black hole a critical path service like the balance reader. Will this result in a graceful degradation of the customer experience? And so you want to think through that. And if you have some ideas, you can share in the chat. So if we make this the balance reader, and as you look here, you can see it on the architecture diagram. So if we make that balance reader unavailable, we make it unreachable. And this is what we call a black hole attack in Gremlin. It's a specific attack where we make that unavailable. What will occur to the application? And if anybody has any ideas, feel free to guess in the chat and let us know if you have any ideas. But what do you think will happen? Will we be able to use the website? Will we be able to see what the deposit is? Will we be able to deposit funds? And these are questions we want to ask ourselves. Now, my guess would be that if we black hole the balance reader service, we might see an error message that says unable to read the balance, something that's user friendly. We also hope that we would get a loading or that there's some type of issue with the balance reader service because it's no longer available. Or maybe it's just really well built and we just fail over automatically. So maybe if that one service was unavailable because it was running on Kubernetes, maybe there's going to be some redundancy and we'll be able to actually fail over. So let's see what we can do within Gremlin. So you can select the balance reader service, and we're selecting it as a Kubernetes replica set. And already we're learning a lot because we see that within the UI in this visualization on the right, it says that there's only one pod impacted. So if there were multiple pods with the balance reader service, then we'd actually see, 2 pods impacted. So this already shows us something that when we want to run this chaos engineering experiment, we're going to make all of the balance reader service unavailable because there's no secondary pod. So going back to blast radius, this may not be the experiment that you want to start with because, again, we're making it all unavailable. So this is what it looks like when we actually run our experiment. The balance reader appears as --. And if you think about it as a user, this can be really confusing. So if I was building this as a real internet banking application for a bank, they'd be like, no way. We would get so many support tickets if this really happens because that's not even a real error message. And this can make the user really confused. And then they might start picking up that phone and calling the call center, which then increases the cost of having to answer all those calls. And there can be a lot of problems. But we also want to check other functionality too. So how does this affect other dependencies. So the user is actually still able to make a deposit of $1,000 while the balance reader service is in that black hole. And you can see this in the transaction history that we added money to our bank account and we get a successful message, but the balance is still dash, dash, dash. But if we try to make a payment, we're unable to do it. And I want to point out here, if we look at this error message, it's an engineer-friendly error message, but not a generally customer-friendly, customer-facing message. And so I want to take a moment here to think about, how do you think your friends or your families, your moms, your dads, your grandparents who don't work in tech, do you think that they would know what this means? Or are they going to call you because they know you work in tech, so therefore you can fix anything, and ask? Because I can tell you right now that anytime there is any sort of incident like with Facebook or my mom's bank or Hulu, my mom calls me and asks me if I can fix it simply because I work in tech. But it's important to understand and think through this. What does this look like to your customer, to your user? I get these errors a lot with my current bank, and I'm actually changing banks because I hate this type of error. I actually hate getting errors at all. My bank goes down too much. And that's something that we also want to think about when we talk about the reliability of our systems, because customers can go set up a new bank account in 5 minutes from the comfort of their home in their pajamas. The market is very competitive, and we want to make sure that our customers are having great experiences. And so that's why we're thinking about reliability. And we know that things will happen. So how does the user see issues? How do we represent problems to them? Do they even notice that there's a problem? Is there a way to hide problems from the user and gracefully degrade? Maybe even if possible, could we remove a component from a web page if it's not working at the moment? There's a lot of things that you can do to allow for graceful degradation that makes a better user experience. And let's take a step back and think through this. And we can go back in time to that AWS outage, the one years ago. Remember the S3 one? Not the most recent one. So when S3 went down, I don't know who here remembers the error messages that they got, but it was something along the lines of all of your data was deleted. And there were all these messages, but the data was actually there. It's just that the thumbnail preview was unavailable. So all the users got that friendly X when we logged in, and you could see that the data was there, but the thumbnail preview service wasn't working. But once you clicked into it, you could see the files. But thinking through that, those error messages really increased the amount of stress on those users. So it's important to, again, think through that. Now, if you're interested in learning more, check out the free environment. It's totally free to spin up. I'm actually going to copy the URL right now into the chat so that you can all check it out. So there is the URL to get to this in the chat. And what you're going to do, I'm just going to post some instructions in here in the chat so that you can all kind of get started with this. Actually, maybe I'll do that at the very end because I'm a terrible multitasker. But you can go to this GitHub link right here and get the Gremlin information to install Helm. Now, with that, let's kind of go back to our demo environment because I want to look at another interesting thing to test because there's different types of failure modes. So I want to look at the transaction history service, and let's look at how would a black hole potentially impact that. So this is the transaction history here. And you can see what it looks like when things are good. You can see the credits and the debits. You can see who made the transactions. You want to see, are we going to get a graceful degradation of this service if it's made unavailable or not? So during our experiment, we can see that the transaction history is not there. We get an error that says could not load transactions, but we can also see that our deposit is successful. So this is better than the balance reader, as at least we aren't getting a dash, 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 and we have more of a user-friendly experience that doesn't talk about get. But how can we mitigate against a black hole, right? That's the next question. And before, if you remember on the balance reader, there was only one pod. So now we're going to make it two. We're going to scale replicas. And if you're interested in Kubernetes and learning more, then this little part might be about you. But we're going to run the command kubectl scale deployment transaction history. And we're going to give it 2 replicas instead of just 1. And so we'll do this for the transaction history one for this example. So run the command, and now we can see, we can look in terminal, and we can see kubectl get pods. And yes, now we have 2 pods that are now running for the transaction history and be able to show us that data. So now we can do a smaller blast radius chaos engineering experiment, because if you remember before, when I was selecting just the 1 pod and sending it into a black hole. So now let's send 50% of the transaction history pods into a black hole. So just one of the 2. And you can see at the bottom on the right, 50%, one of the 2 pods impacted. I've selected the transaction history replica set, and you can see the 2 pods. They're the 2 green little dots in the visualization. So now think through, what is your hypothesis now? And feel free to guess in the chat if you would like. If we send 1 of 2 of those transaction pods into a black hole, will we get an error message? Will things be okay? Will things get worse? The interesting thing here is that you're never really going to know until you run the experiment. You're never going to be able to guess exactly, because it's really hard to do. If it was, we'd probably all be millionaires because we guessed the exact numbers of the Powerball. So let's run that experiment and we'll see. So we're going to look at our architecture diagram just to be able to really visualize this and understand what's happening. So we have our 2 transaction history pods. We have the 2 replicas. And what actually happens with this is that there will be a very, very short outage, not visible to the human eye, because that other pod will take over. It'll say, this pod is not reachable. I'm going to flip over to that other pod. And this is actually what occurs when you test this out with Gremlin in real time. So this is actually great, because now we don't get an error message. All the user gets is just the data. And you're still able to see all of the transaction history. You no longer receive error messages. So this is a really nice way to fail over that service. And what we learned here through this experiment is that we needed to make sure that we had 2 pods instead of just 1. We learned an area where there was a big vulnerability that we were able to make the customer experience better. So again, here's the URL if you would like to take a look. I'm posting that in the chat at this Bank of Anthos repo, so take a look there. But now that I've talked a little bit about chaos engineering, I'd like to talk about that second key practice, which was game days. So game days are a really great team building exercise, and it's something that Accelerate talks a lot about in the book. They're a great way to build relationships within an organization. As I mentioned, part of chaos engineering is we're building that culture. And according to Accelerate, this is a cultural must do to become a high performing organization. And this is very, very true, because game days not only help you to improve stability or reliability, definitely tempo, because it enables you to work closely with other teams that you want to have better relationships with, especially if you're in those larger engineering organizations. So let's take a look at game days. And so the goal with game days is cooperative, proactive testing of our systems to enhance reliability. So by getting the team together and thinking through that system architecture, you can test hypotheses. You can evaluate if your systems are resilient to various kinds of failures. And if they're not resilient, then you fix them before those weaknesses impact customers, kind of like we just did with that little Bank of Anthos demonstration. So Just an example of a game day, what you really want to do is invite 4 or more people to attend. And it's always a great idea to have at least 2 teams, because you want to know if you have some type of failure, how does that appear to the other team? Or if they have some sort of failure, you want to see how that affects your systems. And that's why these are so great. You're doing this in real time. You're practicing together. This isn't happening during an incident, which is why we have these game days scheduled on a shared calendar. And if there is an incident going on, we reschedule those game days. You're not doing this at 3 o'clock in the morning on a Saturday, but instead you're doing this at 10 a.m. on a Tuesday with coffee on a Zoom or whatever day of the week you choose to do it. And you don't have to spend hours practicing game days. So some folks think that game days have to be an entire day or multiple days. You can run experiments in a shorter period of time. And we recommend at least 30 minutes in the real world, but 30 minutes to an hour is a really great time frame to have a game day. Oftentimes we see folks spike load, maybe using like Gatling or JMeter, and then they'll introduce different types of failure modes with Gremlin. So for example, if you use JMeter, you could be like, all right, let's send a bunch of requests, but now I'm going to spike CPU with Gremlin because our auto scaling is based on CPU, or maybe it's based on a mix of CPU and requests. So that allows you to create that situation where auto scaling should occur, and then you can see that it works. And then when the traffic subsides and that CPU attack finishes, it'll go back to normal and it's going to scale back down. And you can run one of these for 60 seconds. And so this is going to help you with some other things too, if you're thinking about cost management with cloud infrastructure. Because one of the things that we want to do, right, is keep our costs low. And a lot of SREs, this is what we really care about too. Like, how can we say, we saved this much money? We were able to make sure that we were able to quickly scale down when we don't need to be running a large number of machines in our fleet. So these are things that we want to think through with our game days, and part of that ROI that we are showing. Because again, how did we save money? How did we keep those costs low? Now, as I mentioned, here's just some ideas on how to plan a game day. You can find a lot of this information at gremlin.com/game day. So 30 minutes to 1 hour sessions. And as I mentioned, you want it to be at least 2 teams, because this is going to really help with understanding how dependencies and critical services work between the teams. You can do it with smaller teams. Decide on a communication tool. So are you going to use Slack or Confluence or a Google Doc? Hopefully it's not going to be email. We use Slack as one of our communication tools here at Gremlin. At PagerDuty, we practiced Failure Fridays, which were our game days, because iteration is very important. So it was Failure Fridays. These happened at 2 o'clock after lunch. We communicated using Slack. So you want to plan and design 2 to 3 use cases, and you want to make sure that as a team, you're getting together and you're reviewing that target application architecture. As I mentioned before, just the conversation around that can really help you understand quite a bit more. And then you decide that blast radius or scope. And as I mentioned, you want to look at things that are going to be customer impacting and hypothesize expected behavior. So if we do this, we expect that. And then identify those conditions under which you are going to push that red halt button, because maybe you learned something about your system and it started to affect customers, and you want to identify those abort conditions ahead of time. And then you'll assign your roles within the game day structure. So that is who is going to be running the experiments, who's going to be taking notes, who's going to be observing. And then you'll schedule the game day. As I mentioned before, we're not trying to catch people off guard. So this should be scheduled on a shared calendar with a lot of visibility. Invite other teams to just watch and observe the game day. It can really help those other teams understand how to run these themselves. And it's a great way to mentor throughout your organization. And then document those results. So where are those results and those learnings from the game days? And where can other folks in the organization look at those results and maybe even run some of the same experiments themselves? Share that within your organization. We have a place within Gremlin where all of those game day notes are, where we can find the information, and anybody can go in and look at those and understand the learnings, anything that we found, hypotheses that we validated, and so on. And so there are some other examples of game days here too that we can look at. There's dependency testing, capacity plan testing, auto scaling testing. And, capacity planning, that's actually an interesting one. So we've seen outages when folks tried to scale up during a peak traffic day, but they didn't have the limits set correctly. And they weren't even allowed to do that because they didn't have the permission set up. And then there were caps and they just couldn't scale. So that's a bad situation. And you definitely want to test that you don't have caps in place in a bad way that impacts you. You want to understand how the permissions are working for the teams to make sure that people can do the things that need to happen, especially when we're preparing or in the middle of a peak traffic event. So here's just a scenario planning template. As I mentioned, you can find this at gremlin.com/GameDay. And things that we're looking at and that we're documenting and we're starting off with is, what's the attack target? What's the attack type? What failure condition are we looking to simulate? And a great thing that you can think through here too is if you've had an incident or an outage that has been resolved, go ahead and go back now and run a chaos engineering experiment to validate those fixes and to prevent yourself from drifting back into failure. Other things that you want to note are what are the expected behavior and risk, and then what is the post-attack state or the impact. The third thing that I mentioned was disaster recovery. And for disaster recovery style events to be successful, you can see that an organization first needs to accept systems and process failures as a means of learning. And it's really one of the things that we talk a lot about here is that failure is going to happen. We expect it, but are we learning from that failure and are we making our systems more resilient? And so we want to also practice those disaster recovery scenarios to make sure that we are improving tempo and stability. And an example of one of those is you would want to invite 4 or more people to attend. And, fail over 5 core services using the Gremlin black hole that I showed you earlier. It's actually safer than one of our other attacks. It's a shutdown because it's faster to recover. And then the minimum time required for this is at least 5 minutes. Again, you want to make sure that your systems are in a steady state prior to running these experiments. And then the next question that we get a lot of the times is, can you automate this? And yes, you can absolutely automate your chaos engineering experiments. I mean, we recommend that you codify your chaos engineering experiments because you want to make them shareable. You can do version control. You can show a history of all your experiments. You can save them. Within Gremlin, we actually have scenarios that you can design and share with teams. There are some recommended scenarios that are already designed for you. So it's something that you want to look at. What you do within Gremlin, you add multiple attacks together in a scenario. That you can use the API or you can integrate into these chaos engineering experiments, and then you integrate that into your CI/CD pipelines. So you might do this for production readiness. You might say, you need to pass this number of chaos experiments, reliability experiments to pass through before you can ship your new service to production or before you can ship your change. Maybe if you're going multi-cloud, you want to make sure that all the code can pass through these experiments first. I mean, we all know that lift and shift is a thing, but is it really? Because it's not a thing that really works out well because these environments are so different. So there's a lot of fine-grained detail there. And this can help you with automation of these chaos engineering experiments. And it's really nice because you don't have to go around teaching everybody SRE best practices, you can just build a system that can quickly go in and check if you're giving people tips so that they can do better work going forward. And with that, I just want to let you know that you can actually become a Gremlin certified chaos engineering practitioner and a Gremlin certified chaos engineering professional based off of a lot of the things that I've talked about today. This is a free certification that we have. Just go to gremlin.com/certification. Check it out. You'll have some access to some training and development there. And then with that, I would like to open it up for some Q&A, or maybe even take a look at the chat and see what questions we have. So let me just go ahead and pop that over here. As I mentioned, I am a terrible multitasker, so I'm going to go ahead and stop sharing the screen so I can look at these questions here. So I've got one question here, which is, how do you recommend approaching testing in production? And again, as I mentioned, it's really important to look at that blast radius. So starting small, and also making sure that you set those abort conditions and that you understand what the success of your customers is going to look like, and that you're not impacting them. One of the things that I think sometimes we forget about, like, all of the things that we're doing is in service to our customers. We're building reliable systems for our customers. But sometimes we get really involved with those ones and zeros. And we do forget that there is a human on the other end that might be trying to do something that might be having a bad day. So, one of the things that you've probably all experienced chaos engineering before, if you have Netflix, you've clicked in and sometimes you see that error that says we're having trouble playing this title right now. And then you hit retry and it works, and you can watch Bridgerton. So when they are running their experiments, they look at one of those key metrics, which is stream starts per second. If they start to see that impacted, they roll it back, because that's one of their abort conditions. So start small, set those abort conditions, and make sure you're paying attention to the customer experience. So here's another question. When thinking about chaos engineering, how do you know where to start? Like, what experiments do you first run on a service? So some of the things that you can look at are, starting with resource failures. Maybe, start small. Start with CPU, disk, memory, I/O. This is what the cloud was built for. Does auto scaling work? And then from there, you can move on to, dependency testing and things like that. So you want to start where you have some baseline metrics. So here's another question. How do you handle a situation where your service depends on another service, but that service is unreliable? Whose responsibility is it to keep it running, or does it become a shared responsibility? And so that's a great question. I mean, there is a concept of full service ownership where you are responsible for the services and the applications that you have built. And it's important to make sure that those are reliable and running. So on that service team who built that, it really is their responsibility to make sure that that service is reliable. Now, your responsibility is if you have to understand if your service is dependent on something that's unreliable, how are you going to mitigate against that? This is a big part of organizational culture, and being able to have those conversations with other teams and being able to understand where those dependencies lie and who's dependent on what. But I would say that, it is the responsibility of the service owner to make sure that their service is reliable, and it's your responsibility to help communicate that with them. So I hope that answered that question. It looks like that is all the questions I have right now. So with that, I'll give it just another minute for any other questions. Looks like Cody's back. Hi, Cody.
Hi, Julie. How are you?
Good.
So we can give the audience a few more seconds to send in any questions while I give away some gift cards. Does that sound good?
I love that. That sounds great.
Perfect. So these are for 4 $25 Amazon gift cards. Our first winner is Francis G. Our second winner is Melanie T. Our third winner is Bola R. And our fourth and final winner is Boyan V. So to the four of you, keep an eye on your inbox to claim that gift card. And if you don't see an email, just check your spam folder. And I'll also take this opportunity to remind everyone that this webinar was recorded. So you'll find it living on the DevOps website at devops.com/webinars and look in the on-demand section. You should also be receiving an email shortly after we conclude with a link to access that recording.
Thank you. And thank
Julie,
you, Cody. Thanks to, or congrats to all the winners of the Amazon gift cards. And again, if anybody has any questions for me, you can find me on Twitter at Julie_Gund or email me at Julie@Gremlin. We also have a chaos engineering community, so you can go to gremlin.com/Slack and join the chaos engineering community and find me there.
Awesome. Julie, thank you so much for being here. I really appreciate the time and the conversations that we were able to have before we went live. So it was really nice to meet you today.
You too, Cody. Thank you.
I'd like to thank Gremlin for sponsoring today's webinar. And my final thanks, as always, goes to you, our audience. We really appreciate you spending your time with us. Please, we just ask for one extra moment to fill out our post-webinar survey. But other than that, we hope to see you at a future Techstrong Learning webinar. Everyone, have a great rest of your day.